Okay, next we're going to talk about function notation. So when we see this f with parentheses x, it is read as f of x. That should not be anything new. F, G, and H. So f of x, G of H, f of x, G of x, H of x. All of those are the same. It's just the name of the function. So don't stress about that. It's to clarify that, you know, function A is different than function B. So f of x and g of x, that type of thing. All right, so if I have f of x, it's always equal to y because the value of the function at the number x. That's why that is the reason why it always is equal to y. So f of 2 equals 9 must mean that 2, 9 is on the graph, because this is my x value and it equals my output, which is known as my y value. Okay, I am actually going to go through all of the problems that are listed. If you try one and you're like, this is easy, you are welcome to skip ahead. If you want to work on the activity first, and then if you think one is complicated, come back and find that spot in the video, you may do that. You are not forced to watch this beginning to end. Okay? Just wanted to throw that out there. Go ahead and hit stop now if you feel like this is a review, because it technically is. All right. F of 2 just means that everywhere that there's an x in my function, I am going to plug in 2. The proper word for plug in is substitute. So substitute in 2. If you're feeling a little bit lazy, you are welcome to just type this entire line into your calculator. That's okay. If you want to test your algebra skill, or because you have taken the summer off, I understand. Remember, you do exponents first, then you multiply, and I get 2. So that means that 2 is a point on the graph. If I were to graph 2x squared minus 3x, I would indeed find that 2 is a point on the graph. All right. B, f of x is just the function. So 2x squared minus 3x. F of 2, hey, I already did that. So for time's sake, I'm going to save some time. I know that that equals 2. If I did not know that, then this is what I would substitute in for that part of the problem. Okay. How does f of 2x look different? Well, everywhere that there was originally an x, so sometimes I put a box there to tell myself this. So the original function was 2x squared minus 3x. Everywhere there was an x, I put a box. And instead of an x, I'm going to put whatever's in parentheses. So in this case, 2x and 2x. Here's what you got to think. When you put something in that box, it automatically becomes a set of parentheses. It's its own entity there. Why does that matter? Because a lot of people will forget to square that 2 and make it 4. And then multiply 2 and 4 together to get 8x squared minus 6x. All right. Then it gets really tricky. I'm going to make my box a little bigger here, because notice what's in parentheses is a little bigger. So x plus 2 has 2 different spots that it goes in. This end part here should be a little bit easier there, right? Negative times positive, negative times positive. Okay. Now, here's the part every year Someone is going to make this mistake. Let's let it not be you. Okay? X plus 2, quantity squared, is not x squared plus 2 squared. Okay? Remember, you must think about it as multiplication. So something times itself. Most people, when they see that that's a binomial times a binomial, they remember you have to FOIL, you have to distribute, whatever math term your teacher used. Okay, so x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. And then I have the tag-alongs back here, the minus 3x minus 6. Then so I'm putting this in multiple steps for the purpose that you follow along. If it does not take you this many steps to do this problem, that is absolutely 110% okay. Let me tell you a trick. So if you don't want to have to write out the binomial and then actually multiply it every time, you can remember that it's the first term squared, so x squared, in the beginning. It is the 2 squared at the end, but there's always a middle term. How do I find that middle term without going, the long way? Take the first term times the last term, so x times 2 is 2x, and double it. So if I double 2, it's 4x, which my work there verifies that that's the case. Hang on to that thought because we will do it again in G. All right, last, I'm going to clean that up, meaning that I'm going to distribute the 2 and then combine like terms. Whoops. All right. Oh, wait, I had x minus 6. Mistake. So 8 minus 6 is actually positive 2. See, it's okay to make mistakes. Just try to find them and correct them. All right. E and F should go relatively quick. So if there's a negative x on the inside, everywhere that there's x, I replace with negative x. So then we remember our properties. Well, a negative times a negative is positive. So that's really just positive x squared. And then negative 3 times negative x is positive 3x. All right, how is a negative x different than negative f of x? Well, negative f of x means the negative on the outside function itself on the inside. So that just changes the signs. That's your final answer. And I love this problem because you will do it often now. At the end of this course, so like I'm talking May, you will be introduced to something called limits, and you're going to see this again. So, and then it's the basis of calculus. So if you are moving on to AP calculus or calculus in college, you're going to see it again. Okay? Math is fun that way. Just like before, everywhere there is an x, I am subbing in x plus h. I'm going to use my trick that I taught you in D. So the first term squared is x squared. The last term squared is h squared. And to find my middle term, I'm going to do x times h and double it. So it's 2xh. Distribute my negative 3. Clean it up. See how that skipped 2, like go back at D. That skips 2 of those steps. And that's less work for you if you remember the shortcut. If you don't remember the shortcut, the long way works as well. It's the fun part about math. As long as you get to the answer, you can take the long way around. All right, so notice we have 0 like terms here. So this is my final